Assalamualaikum and hi, my name is Muhammad Rabi bin Muhammad Hari. For this project, I will explain about the introduction of this project study. The background study. As we know, geotechnical engineering is a branch of civil engineering that focuses on how earth's elements behave and interact with structures that are constructed by humans. In geotechnical engineering, they have some laboratory tests and on-site experiments that we use to know some kind of geotechnical characteristic parameter of soil, such as field bend shear test, cold penetration test, Macintosh prop test, and the last one is the field density test. So the aim of this study is to explain and compare the information that we get from the related case study for these four experiments and how they address geotechnical engineering challenges in the civil engineering fields. Other than that, the objective for this project is first to understanding of the purpose and detailed process involved in conducting these four specific geotechnical experiments. Second, to conduct comparative analysis of these four geotechnical experiments. And the last one is to explore the practical application of this experiment within the civil engineering fields.
Assalamualaikum, my name is Muhammad Nur Afan bin Nur Azman. My metric number is TF220083 and I will be presenting about field bench test. First, the objective of the field bench test is to determine the in situ and shear strength of saturated fine soils, particularly clay. This test is commonly employed in geotechnical investigations to assess the soil stability and its resistance to shearing under ambient conditions. Then we will go to the benefit of field bench test. Firstly, it provides a direct measurement of the undershear strength of the source without the need for complex laboratory testing. Second, it assesses the soil in its natural state, capturing the effects of soil structure and in situ stress conditions which might be altered during sample extraction and transportation. And finally, it is rapid and cost efficient. The test is relatively quick and expensive compared to the other in situ testing method, like standard penetration test or cold penetration test. Next, we will go to the limitations of the field bench test. First, the applicability is primarily limited to fine-grained soils such as clays and silts, not suitable for coarse-grained soils or soils with significant amounts of sand or gravel. Second, it may overestimate the undrained shear strength in highly sensitive clays due to remolding effects. Third, effectively mostly at shallow depths, typically less than 30 meters, difficulties increase with depth due to equipment handling as alignment issues.
Macintosh prop test is a site investigation that is usually used for project construction and preliminary design of embankment. The field test is run to determine the bearing capacity of soil and its layers. There are two types of standards to run the testing, which are JKR prop test standard and Macintosh prop test standard. In comparison, there are several slight differences for both of the testing methods. Firstly, both standards differ in the length and the degree of the penetrator, with the degree of 30 degree for the Macintosh prop test and 60 degree for JKR prop test, which make the standard more acute and shorter compared to Macintosh prop test. Next, Macintosh prop test is harder to be applied to the on-site work compared to the JKR prop test. Macintosh prop test consists of several connections with the height of 450 millimeter with the 4.5 kilogram weight of the hammer, while JKR prop test only consists of 500 millimeter height in a single connection with 5 kilogram weight of hammer. Macintosh prop test can be used up to a maximum depth of 15 meters, making it a cost-effective and efficient method for soil investigation. However, there are limitations for the test where the test can only be penetrating medium-strength soil and gravelly ground. So for the test, it helps the engineer to decide types of foundation, whether it is a shallow foundation or there is a piling need to be done at the site.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Zainuddin. My matrix number is DF220148 and today I will present about the cone penetration test. The definition of cone penetration test is a technique for identifying soil strata and determining geotechnical engineering. The recent advancements shows that the cone penetration test is recognized for determining the in situ strength of pavement layer and substrate. The cone penetration test can be applied into the pavement engineering by strength and compaction, which is analyze the pavement layers, substrate evaluation by assess the quality and strength of the substrate, and lastly the pavement state assessment by evaluates current pavement condition to ensure standards are met. There are many advantages of using the cone penetration test, which is a quick implementation because fast and efficient, cost effectiveness because lower cost compared to the other methods, minimal requirement because using a less labor and equipment needed, and lastly minimal soil disturbance because the CPT ensures the accurate in situ condition assessment. But there are also the challenges by using the cone penetration test, which is high fraction ratio because issues in rework and in situ residual soils are meta-sedimentary formation, tropical residual soil, effective characterization despite the challenge, and lastly transient high pore water suction because the CPT require more comprehensive disciplinary test. In conclusion, the cone penetration test is complexities in application because they are particularly not in initial terrains, and advocacy for research and development calls for standardized procedure and improved technology to enhance the CPTU accuracy and reliability. That's all from me. Thank you.
Assalamualaikum and hello everyone. My name is Muhammad Mirza bin Masizam. I will present about field density test. The type for this test is sand cone density. The main purpose for the test is determining the in situ density of compacted soil, contributing to the stability and longevity of infrastructure such as road, embankment, and foundation. The recent advancement for this test is nuclear density goggles and electromagnetic density device offer faster and more precise measurement. The sand cone density test remains a cornerstone in geotechnical engineering for measuring soil compaction. The benefit for this test is simplicity and cost effectiveness. Limitation for this test is the test can be time consuming. Second, less effective in environment where it is difficult to maintain a stable and flat testing surface.
The discussion part for this project will explain the comparison of each test. The relationship between these four tests is that they all serve as geotechnical tests designed to determine various geotechnical parameters of soil. Each test provides a unique insight and measurement that are offering different objectives, methodologies, application, and limitations that contribute to a comprehensive understanding of soil characteristics. So this table shows the summary comparison for each test. The first test is field bend test. The objective for this test is to measure shear strength of constructive soil. The application for this test is for the foundation design and slope stability. The advantage for this test is this test can measure direct shear strength, and this test is quick. And the last one, the test is minimal disturbance. The limitation for this test is ineffective in sandy, gravelly soil. Second test is field density test. The objective for this test is determining the in situ density of compacted soil. The application for this test is for the compaction quality, earthwork project, and the road construction project. The advantage for this project is direct density measurement and the quality control. And the limitation for this project is time consuming. The third test is Macintosh probe test. This objective test is to assess soil consistency and approximate bearing capacity. So the application for this test is soil consistency and preliminary site investigation. So the advantage for this test is simple, portable, and cost effective. The limitation for this test is the test limit at a certain depth and less precise. The last test is called penetration test. The objective for this test is identifying soil strata. The application used for this test is for soil stratigraphy, relative density, and the shear strength. The advantage for this test is this test detail continuous data and wide applicability. So the limitation for this test is specialized equipment, high initial cost, and the obstruction by hard soil. Finally, the last part of this project is the conclusion. In conclusion, the choice of soil testing method depends on the specific requirement of a geotechnical project. Each method has a specific strength and limitation, making them suitable for different type of project and soil condition. The understanding of this factor ensures that the selection of the most effective testing method, leading to accurate and reliable geotechnical analysis. That's all from us. Thank you.